Hey, what's up guys? In this video I'm going to show you how to make a scatter plot using a TI-84 graphing calculator, and also how to find the correlation coefficient to see how strong the association is between two quantitative variables. So in your graphing calculator, first of all you have to input your data. So the way you guys do this, you guys go to Stat button right here. It's going to give you guys some options, and option number one is Edit. You are going to edit to list, so you press enter or press 1, and you guys should have list 1 and list 2 to input your data. Now the data I have here, I have for list 1 the number of miles a used truck has and the price when the truck is sold. What is the price according to the number of miles? We know that the more miles a truck or a car has, the price is going to go down, it depreciates. So we can look at a scatter plot to find the association or relationship between the two quantitative variables. So you guys go down the list, make sure you guys have all those numbers, and any number or any x variable needs to be connected with the y variable. So for example here, the 29,953, that's miles. So the price for that truck that has 29,953 should be around 41,995. But we can actually see the association with a scatter plot. So once you have the two lists, list 1 and list 2, you are going to press second, stat plot, which is this button here, and you're going to have different plots that you guys can graph. Now we usually graph only one plot at a time, but you guys can have multiple plots. If you guys graph only one plot, make sure you guys have the other ones off. So plot 2, 3, 4, and you guys can see they're off, off, off. But I'm going to use plot number 1, and it is on. I see that on top here is on. So I want to choose the type of graph that I want. So I'm going to go to this one, and you guys see the cursor. I am moving to different graphs. So the scatter plot is the first one. And then you guys have your x list, y list. Make sure you remember which one is your x values, which one is your y values. So I am saying the number of miles will be my x variable or my explanatory variable. That's going to be list 1. And my response variable or the y value is going to be the price of the truck or used truck. So the mark doesn't really matter. You guys have your marks here. You guys can choose either one. But notice that in Y list, I do not have the correct list. I have L3. So I want to choose L2. So in your graphing calculator, to use a different list, you guys press the numbers button, 1, 2, 3, 4, 5. Notice on the top in blue, it has L1, L2, L3, and so forth. So to get to that list, I want to change that Y list to L2. I'm going to press second, and number 2 is going to change it to L2. So make sure you double check your list when you guys have your X list and Y list, that you are using the correct list, L1, L2, or whatever list you guys are using, depending what you guys are using for those variables. So I have my scatter plot right here. I have my list. I'm going to press graph. Sometimes the graph doesn't come out. So if it doesn't, like in this case, it doesn't come out, we can zoom, press the zoom, and it's a little bit different in every calculator. But if you guys go to zoom stat, in my calculator is number 9, zoom stat, that's going to zoom in into the statistic that we just input. So you press that one, and there's a scatter plot. You guys see the points, your x-axis is on the bottom, your y-axis, and in statistics we call that your explanatory variable, which is x, and your response variable is y. Now, how strong is the association? We see that the points are a little bit close to each other, not too much, but we can actually see a form. It is decreasing. If you think about a linear function or a line, the line will go down, decreasing from left to right. So we know the slope is negative. But in order to find the correlation coefficient, first of all, you have to make sure that your stats wizard is on. So how do you do that? You're going to go to mode right here, and it's a little bit different on every calculator like I mentioned, but if you guys go down the list down the list, and you guys will see two stat options: stat diagnostic and stat wizards. So make sure that both of them, stat diagnostics is on and the stat wizard is on. So mine is on, the other one for the wizard is on. When you guys have those off, it will not give you guys the correlation coefficient. So make sure they're on all the time. Once you guys are on, you can press second mode. That's going to be quit this screen. So second mode. And you guys, to find the R coefficient or the correlation coefficient, you press stat. You guys are going to go to calculate right here. And we are using the linear regression, not this one. This is for something else that we're doing in statistics, but we don't use that one. We use the linear regression in the form a plus bx. So in my calculator is number 8. Like I said, every calculator is a little bit different. So the linear regression, and that's a line, a plus bx. So you press that right there. Make sure you guys are using your correct X list and the Y list. So L1, L2, I'm checking my list. That is correct. Don't worry about the frequency list or store regression equation. You can store it in an actual Y value or Y equation, like this one, Y equals. But we don't have to, because you're going to write this on paper. But you guys can calculate. And once you calculate, it gives you guys everything you need for the regression line and also for the correlation coefficient. So notice the Y equals a plus bx, that is your regression line form. You have your y-intercept and the slope. So keep in mind, a is your y-intercept and bx, or just b, is the slope of the line. So here we have a y-intercept of 38,271.48419, and your slope is negative 0.16324, and it keeps going. But it is negative because we saw that the scatter plot, the relation was going down, the direction of the points was descending, was going down. Now we do have an R squared and an R. R is the correlation coefficient. Now that is the strength of the association between the two variables. So we do have miles driven in the truck and the price that is sold, used car or truck. So my strength is negative. You see the negative 0.8155, and it keeps going. You can round to 2 decimal places, negative 0.82. So that's a somewhat strong association. Remember that as correlation gets closer, or I should say the correlation coefficient gets closer to -1 or +1, the strength becomes stronger and stronger and stronger. Is it bad if it's a negative correlation? It's not. Sometimes that's what we want. We want a negative correlation. Sometimes we want a positive correlation, but it doesn't mean that it's bad. You just need to know what the context of the problem is, what the data represents, and you guys make sense of the problem. So here we have a negative association or correlation, negative 0.8155, or like I said, you can round to negative 0.82. Now let's talk about R squared. R squared is the correlation of determination, or not correlation, the coefficient of determination. R squared tells you how much of the data can be explained by the least square regression line. So when you look at R squared, here we have 0.66505. That's a decimal that you can turn into a percent. So my actual percent will be 66.5. So 0.665, you move the decimal 2 to the right, and you can say 66.5 or 50. You can either say 51 because 0, you can round to 1. So 66.51% of the data can be explained by the least square regression line. Or you can say the 66.51% of the data is accounted for. That's another word that we can say, accounted for by the least square regression line. So it's just putting everything together. You guys notice that I do have the least square regression line, and on the top, let me just put that LSRL, least square regression line. We do have the y hat equals 38,271.48 minus 0.1632x. So that's my slope right here, and my y-intercept is the 38,271.48. R squared is in percent, so 66.5%. So 66.5% of the data can be accounted for the least square regression line. The higher this number or percent is, the better. But right now we have 66.5. It helps you to determine how much of the data you can rely on. So in somewhat, you can say that you can rely on this line, the least square regression line, on about 66.5% of the data. R is the actual strength of the association. So keep in mind that R is between -1 and +1, and let me just write that down. So R is in between -1 and +1 right here, and the closer it gets to -1 or +1, the stronger the association is. If R is really close to 0, then there's no association, weak association, meaning that one variable doesn't affect the other one. There's no correlation. But right here, according to this data that we use for the cars, the trucks, the used trucks, and the price, the association is pretty strong. Pretty strong, -0.82. So that's how you find the correlation coefficient using your calculator. You guys can also look at the graph. Let me try to get the graph again on the screen. So there's the graph. And also, you guys can find the least square regression line by using stats, calculate number 8. If you guys go down to number 8, and that's going to give you guys the options that you guys have here. Make sure you guys use your list and you calculate, and there's your information you need to write the least square regression line. I hope you guys like my video. You guys can subscribe to my channel. If you like my videos, you guys can click that like button. Make sure you guys practice your math, and I'll see you guys later.